All right, in this video, I'm going to cover Chapter 7, Confidence Interval Estimates. So from here, we're gonna study the inference of statistics. It means that we're gonna use sample data to approximate population parameters. So the statistic and parameter, right? Statistic means the sample characteristics such as sample mean and sample standard deviation, sample variance, and then proportion. And then the parameter means the population um, mean and population standard deviations, things like this. So the sample is the subset of population, right? So randomly selected the the outcomes or the items from the population. We can construct the sample. We can collect the sample data. Anyway, so see here inference statistic. By the way, before we go to jump into the lecture handout, please read the lecture slide of this chapter carefully. Okay, you must read textbook or the chapter 7 lecture slide first carefully. Okay, so now inference statistic is using sample data I told you to estimate. So statistic they use the the terminology estimate instead of approximate. So estimate is nothing but approximate. So the estimated population parameters such as proportions of mean and certain deviation, things like that. And then second one is test hypothesis claim about population parameters. Sometimes we need to measure how much we can trust the claim based on the sample data. Okay, so now the based on the population, I'm sorry. So we're gonna figure out, yeah, that claim is just true based on the, I mean, 70% true. I mean, 90% we can trust the based on sample data. So that's what we're gonna study in chapter 8. Now, then point estimate. Point estimate is nothing but the approximation. Okay, so it's single value used to approximate the population parameters. So, for example, the sample mean is unbiased point estimate of population mean. It means that we can use sample mean as approximation. It's a good approximation or actually best approximation to the population mean. Okay, so now estimating a population proportion. So simple proportion p hat is equal to x over n. So that's a simple proportion. X is the number of the outcomes or number of the items what we are interested in a sample space sample data set divided by total number of the outcomes or the items in the sample data set. So it's the best point estimate of the population proportion P. So the P is the population proportion. Okay. So however, we have no indication how good that estimate is. That means how close P is to P. Yeah. Okay. So so without proof, we can say that let's just accept that P hat sample proportion is the best the point estimate. I mean best approximation of the population proportion P, but how the accurate, how just the P is accurate within the close to P. I mean, so now let's see to figure out that. Then we're gonna study confidence interval. It's called CI estimate. Confidence interval is a range of value used to estimate the true value of population parameter. So we're gonna figure out the interval. Okay, so that's a range. Okay, so that we can trust that the population parameter belong to that interval with, for example, the 90% we can trust, something like that. Okay, so that's what we're gonna study that. But let's the let me see. But let's see study more about the meaning of the confidence interval. Okay, so let's see lecture slide. So interpreting a confidence interval. So we must be careful to interpret the confidence intervals correctly. So it's really important before just figure you know calculating confidence interval and all the numbers and then formulas. You need to fully understand the meaning of the confidence interval. So there is a correct interpretation and many different and then creative incorrect interpretations of the confidence interval. So now let's see P. This is a population proportion, right? P is in between 0.405 and 0.455. That's a correct interpretation of that confidence interval. So we are 95% confident that the interval from 0.405 to 0.455 actually does contain the true value of the proportion, population proportion P. What about, yeah, that's the correct interpretation of this confidence interval. Okay, so now then, what about the wrong interpretations? There is 95% chance that the true value of P will fall between 0.405 and 0.455. So what I mean here, so the 95% that is called the confidence level. Okay, so that's the confidence level is normally is given. Okay, in problems, that's the probability that confidence interval actually does contain the true value of the population parameter. So this that must be given. Okay, so now then this is the correct interpretations, and then that's the wrong interpretation. Keep in mind this. So it means that the that's 95%. I told you that we can trust the 95%. Okay, that the population proportion the fall between 0.405 or 0.455. Okay, that doesn't mean that 95 chance. There is 95 chance that the true value of P will fall between here. Or the another wrong interpretation is 95% proportions will fall between 0.05 and 0.455. That interval doesn't, you know, that doesn't mean about the not the sample proportions. And then still, you don't maybe you just don't understand what's the difference between the correct interpretations and then the wrong interpretations. Then look at this here, the process success rate. It means that here 95%, the confidence level of 95% tells us that the process we are using should in the long run result in confidence interval limits that contain the true population proportion 95% of the time. It means that this, for example, this confidence level interval from 20 different samples. So we're gonna they collect the sample data randomly 20 times. So it's for there are 20 sample. We collected 20 sample data sets, and then we're gonna the uh, the figure out whether or not each sample we and then here and then we figure out the whether or not each sample data set the contain the each the what the interval for each data set. We're gonna figure out the confidence interval. Okay, I mean the range of the population proportions. Okay, so these confidence interval, one of them, you see that right there, this one, the green one, that confidence interval does not contain the p. Okay, that's so that 20 out of 1, that's the 95%, right? So 95% of the total sample total all the group of samples, the data set actually does contain the true population proportions. That's the meaning of confidence interval and the confidence level. Okay, so now we see critical value. So next one, terminology. Critical value is the number on the borderline separating sample statistics that are significantly high, low from those that are not significant. So look at this. This is the graph of the distribution of data set. Okay, and then it has bell shape. It's called the normal distribution. And then actually this is the since z equals 0 right here, that's a standard normal distribution. So standard normal distribution has the bell shape as a distribution of the data set, and then the mean is 0, and then the standard deviation is 1. Now in here, see that alpha over 2, alpha over 2 is there, okay, alpha over 2 right here. So alpha is the alpha represent the opposite of the confidence level. For example, 95%, the confidence level, it means that alpha must be 1 minus 0.95, which is a 0.05, okay? So actually that's the area. I mean, so if you just, for example, let's say the confidence level is 95%, it means that the from here to here, the area under the graph is 95%, a 0.95. And then the ARPA gonna be 1 minus 0.95, which is 0.05. That's the area of the here and here, okay? And then since the standard normal distribution, that is the, well, normal distribution and standard normal distribution, that's the symmetric about the vertical line is equal to 0 right here. So area of this guy is equal to area of that one. So now then what? That must be alpha over 2. This must be alpha over the half of alpha for each region. And then the z-score, okay, the z-score, the is the what, that, you know, the separating that area and then this area, I mean this region and this region, that is called the critical value. Okay, so number z sub alpha over 2 is a critical value. There is a z-score with the property that it is at the border that separate an area of alpha over 2 in the right tail of the standard normal distribution. So you keep it right tail, the right tail. Okay, this is g over g sub alpha over 2. What about the z-score in here? That's going to be minus z sub alpha over 2. Keep in mind that. So back to the handout. So what are you going to do? So we need to figure out the confidence interval, right? Given a confidence level. So confidence level must be given in problem. Then you can find the alpha, because you see uh, the alpha is 1 minus confidence level. Okay, and then the once we figure out alpha, then we're gonna find the critical z value using the inverse norm, or the look in the table. But yeah, I'll explain about this, how to find out later. Okay, don't worry about that. And the margin of errors. So what's margin of error? So finally, the confidence interval has a form like this: Pn minus E, and then P, and then P plus E. You see that here? That E. So actually, confidence interval P, I mean the population proportion P, is within the P hat minus E and the P hat plus E. So P hat is the sample proportion, right? So it's not a big deal to find out because X over N, so number of the, we're gonna find the sample proportion using the formula X over N. That's gonna be P hat. Now what about E? E is a marginal error, maximum likely difference between the samples proportion P hat, the true population proportion P with a given level of confidence. It means this. So E is the maximum likely difference, okay, between the P hat and P, okay? So with a given confidence level, okay? So now then E can be computed by like the Z times square root of P hat times Q hat over N. But yeah, so you don't have to, actually you don't have, yeah, so yeah, so this, yeah, you can, so using that formula, you can find out E, but using the calculator, then easily you can find out E. Okay, I'll show you. So we'll see. For the confidence interval, we're gonna round to 3 significant digits. Okay, keep in mind this. And then the sample is must be a simple random sample. It means that random is should be randomly selected. Okay, and then the conditions of the binomial distributions are satisfied. There are at least 5 successes and 5 failure. So what that means is a proportion, the number of the, for example, number of the outcomes, or the items you are interested in must be greater than 5, and then total number of the data set, then sample must be greater than or equals d10. Okay, so now then, example, we'll see. Find 94% countless interval estimate for a proportion of Americans who are registered to vote. Okay, so it's 95%. This is the confidence level right here. So we can figure ARPA, which is 0.05, because ARPA must be what? 1 minus confidence in level. So 1 minus 95%, which is 1 minus 0.95, which is 0.05. And then what? So we're gonna divide ARPA to half and half. As you can see that here, this is confidence level right there, and then ARPA was the 0.05, and the half of 0.05 is 0.025. Is ARPA of 2, ARPA of 2. This is area, okay? That doesn't mean the z-score, okay? So area of the both left and right tail, okay? I mean for each, okay? So now let's find out the z-score corresponding to that area 0.025 and 0.025 using calculator. Okay, so all right. So actually, when you find out the complex interval, you don't have to find out the the alpha. Okay, so the critical value, but um, but yeah, let's find out the critical value first. Okay, but keep in mind this: when you find the critical value using critical interval using calculator, you don't have to find out uh, the critical value. Okay, so see, first one, you see the distribution right there. Okay, so press second and then press VARS. That's the variables. Okay, so press second button and then press the variables. Then we can go to the distribution. So the normal PDF, that's the when you find out the uh, the probability under the normal distribution, either normal distribution or standard normal distribution, you can use this. And the normal CDF is when you find the probability less than or equals, okay, or greater than or equals under the standard normal distribution or the normal distribution, you use CDF. CDF means a cumulative density function. The PDF stands for probability density function. Okay, but anyway, so you see the inverse norm right there. We just use this one, inverse norm. Okay, and the area is 0.025. So keep in mind is that area means from the negative infinity to the alpha over 2. I mean the negative z sub alpha over 2. Okay, so that area must be um, the left end tail. Okay, not right end tail. Okay, so that's going to be 0.025, 0.0. And then mu is the population mean, and then sigma means population standard deviation. So since we're talking about the standard normal distribution, so z score, I mean this the mean must be 0 and the standard deviation must be 1. Okay, so just leave 0 and 1 like that, and then paste, and then click. Then you see that negative 1.95996, the rounding up in the to get to obtain the 2 decimal places, we're gonna get negative 1.96. This is exactly the same as the number in the handout, right? And then so now how can you find the complex interval using calculator? So you see that here the stack. Okay, we go to the stack, and then there's the read tab right there, and then edit to calculate and test. So we go to the test right there. So a whole bunch of tests. Yeah, we're gonna go through this one, but what we want to do today is you see that one proportional the z interval. So z means the z score, which means that we're going to find out complex interval under the standard normal distribution, where axis represents z score, right? So now the one proportional z interval right there. So we click it. Then x, the let's see, give me a second. That x is the actually what number of, in this example, what the number of adults who register to vote. Okay, so problems example says that the 1000, yeah, give me a second. So in this example, the in a random sample 1009 adults, that's n, right? So total I mean the size of sample data set, right? The 67% were registered. So now see how many then adults in the sample data set register to vote. So this is not a big, it's just we just multiply 1009 times 67%, right? Okay, so all right, so when you multiply the 1009 by 67%, which is 0.67, we're gonna get this 676.03. But 03 is not great, and I mean if you just round up, then you're gonna get 676, right? So 676, that's gonna be x value. So it means that those number, I mean those others registered vote. So the proportion, I mean p hat proportion of sample data set gonna be 676 divided by 1009. That's a p hat, right? So anyway, we go to the stack and then back to test, and then we do one variable z test right here. Okay, so x is 676, and then n is what the size of data set, sample data set, which is 1009, and then see later the problem says that 95%. So we calculate. Okay, then you're gonna get this interval. That interval represents the p hat minus e, comma p hat plus e, and then you see the p hat is a sample proportion also calculated right here, 0.66997, right? So now from here we can figure out the marginal error. So for example, point is the 0.64096, right? So point, give me a second. So here, look at the right number in the interval contest interval 0.69898. That's the p hat plus e. So if you just subtract p hat, which is 0.669970, that number from the p hat plus e, which is 0.69898, we can figure out marginal error e, right? So see, so 0.69898, right? The minus the point 66 and then 9970 to 676. Okay, then we're gonna get 0.0290. So the approximate 0.03, right? Okay, so that's the 0.03. That's gonna be marginal error. Anyway, so in that example, we figured out what the confidence interval and then the critical value alpha, right? Actually alpha over 2, right? Z sub alpha over 2, okay? And then the margin of error, right? Let's see one more example, okay? And then in a test of professional touch therapist to see if they could truly sense a person's energy field, therapists were asked to identify which hand the researcher was near without seeing or touching the researcher. So among 280 trials, that's the sample size, right? The therapists were correct 123 times. That's the X, right? The number of therapists who were actually the who were correct the whether or not just touching the and then construct the 95% the confidence the uh, confidence interval estimate for the proportion of correct response. So 95% is confidence level. So alpha must be what 0.05, and then what using the inverse norm we could figure out the negative z sub alpha over 2, which is the negative 1.96, right? And then what do the research suggest about the ability of touch therapists to sense a person's energy field? Then you use this using the calculator, we can figure out the confidence interval, right? So Let me see. All right. So here, we go to the stack, right? And then we go to the test in the tab, and then we click the one proportion z inverse. We click, and then x was 123, right? 123, and then total sample size is 280. Okay, the C level is 0.95. Don't put the percentage in the C level. Okay, you have to enter the number, not percent. Okay, 0.95 in the calculate. Okay, so oh, okay, let's see. Oh, mistakenly I pressed 2 times. 1 bit of G inverse, and then 123 280.95. Okay, so now you see that here, confidence interval. What we got is the 0.38115 and then 0.9742, right? Okay, so it means that the what the 94 not we what we can 95% we can confident that the population proportion lies between 0.381. Normally in a confidence interval we around in 3 decimal places. Okay, 0.381 and the 0.497. Okay, so which is below the 50%. So right. So now the question is this: what do the results suggest about the ability of touch therapists to sense a person's energy field? So less than 50%, okay, the has the ability to touch the therapist to sense a person's energy field. So then based on the sample data set. Okay, so that's the conclusion of this example. Okay, so now the next one is to find the sample size required to estimate population proportion. So in this one, the problem is kind of backward. So population, we want to find out the sample size, how many sample size required to estimate the population proportions. Okay, so I'm going to cover this one next time. Okay, so and then please read the lecture slide. Okay, carefully, and then I'll just cover this one next time. So let me stop here.